And I really want to see if you guys understand this. If the m's go away, do the m's have any control over this equation if they go away? No. So they don't have. So no matter what I make m, it's going to end up with 4 equals 4. So the equation doesn't care what I make m equal. It's always true. So that's why the answer is all real numbers. I can make m whatever the hell I want to. Yes?
I thought you had said when you started this equation...
I know. I was thinking... So let me... Real quick. I forgot which case I was going to do. That's one case where it gets a little freaky. And the other case where it gets a little freaky would be if I just make this 5 minus m like I said. So I'm going to do it a little quickly. Right? It's the same thing we just did. 5 minus m equals m minus 4. That's one case. Or 5 minus m equals negative m minus 4. Is the other case, right? So I get here 2m equals 9, so I get m equals 9 halves. Is that cool?
Mm-hmm.
So that's an answer. Nothing can take that away. That's an answer also, but isn't all real numbers also including 4?
Yeah.
Isn't all real numbers also including 4? So this is the overall answer, and it goes, oh, 4 too. It's like, I already got 4. So all I got to say is this then.
So you don't, okay.
Yeah, so far I know this is an answer. This is definitely an answer. Well, what happens over here? Add m, 5 equals 4. What does that mean? No solution. So this case, did it give me any answers? No. This case has no solutions. But what's the answer to this? That. Right? I got this already. Did this give me any more?
No.
So that's the only answer to this. Yes, sir?
So what happens if you have like a +3 on the outside of all the absolute
You
values?
want to go there so desperately, and we're not.
Okay.
That would be really difficult. Yeah, if I did this, now we're talking about some difficult shit, to be honest. Right? And you guys might not, you're all like, well, it all looks difficult to me, Jeff. I don't know why that made it more difficult. But if you think about it, that is not easy to control for. Right? This is very contained. That brings in an element outside of my control that I got to somehow handle. You don't want to. Trust me. You don't want to. I won't even make that bonus because that would be really evil. Okay. So enough with the equations. Let's talk about inequalities. Right? Remind me again what absolute value physically uses distance. All right. Let's see. So, inequalities with absolute values.
Is it still 8.5?
Yeah, believe it or not. So 8.5 is equations and inequalities with absolute values. Very quick title for a lot of stuff, actually. So let's start with the what I call the base case, sort of. And actually, let's make it more interesting. Let's do one we can think of visually. Okay. So there's where I bring the absolute value in. We're going to solve this visually, and then we're going to try to come up with a general process to do for anything that I can't do visually. Okay? That's what math is really good at. Let's try an easy one, and let's try to generalize it for the hard ones. That's what math does a lot of things with. Okay. So visually, now what does this say? I don't want the distance between a number and 1 to be equal to 2. I want the distance between a number and 1 to be at most 2.
So wouldn't it be x take away 1, and then it's that sign 2, and then it'd be...
No, let's not do it algebraically yet.
Oh.
Because algebraically it's going to get a little bit weird. But visually this should hopefully be simple. Here's 1. There's 1. I want all the numbers that are at most 2 away from it. Well, what's 2 away from 1 that way? 3. And what's 2 away from the 1 that way?
-1.
So that's the furthest I want my answers to get away, right? Does that make sense?
Wait,
I want the
what's the
distance.
3?
So what does this say in English? I want the distance between x and 1 to be at most 2. If this was an equal sign, my answers would be -1 and 3, I'm done, right? If I want the distance to be equal to 2, it's just those 2 places. That's 2 away, that's 2 away. Why is this different because it's going to include everybody that's...
All the points, all the
Yeah, so it's going to be all these points in the middle. Is this at most 2 away from this? Yeah, it's less than 2 away, isn't it?
Yeah.
So I was thinking about this, like I'm going into a haunted house, I'm like, or something's, there's a monster out there, stay close to me. I want the distance between you and me to be close. So it doesn't make sense, it's like this. I want you to be at most this far away from me and at most that far away from me, right? So we're going down a long hallway, really narrow, so it's basically only one-dimensional. I don't want you to, hey man, whoa, you're getting too far ahead. This scary shit around here, right? Or you guys or come on, hurry up, shit. So I don't want you lagging behind me too much either. Does that make sense? And that's distance less than something says stay close to me. Here I am in the middle, stay close to me. All right, I know I'll keep saying that, but I really want this to sink in. So somehow the answer to this equation has to be, oh shit, here we go with interval notation. From -1 up to 3. That should be the answer. So now we got to figure out how do we do this algebraically to end up there. All right, so here we go. I'm going to do this long way first, then show you the short way to write it, and you can do it either way you want to. So here's algebraically how this looks. So here's the beauty about this. I want you to realize the long way is going to involve using the process we already know, which is nice. That's why I want to start there. So one case would be x minus 1 is less than or equal to 2. One case is always just leave it alone. If this number is already less than or equal to 2, like if it's 1, then the absolute value is going to be less than 2, right? Unless I get too far negative. Right, so now watch. Why don't you stay with me? Does it make sense? If this number is -7, what's the absolute value of -7?
7.
Is that less than 2? No. So this is like my ceiling, but I also need a floor, right? I can't get too far away on one side of it, and that's visually what's going on. I don't want to go too far away up here, and I don't want to get too far away down there. So I want this to be less equal to 2, and I need it to be... No, I really want you with me.
It's fine, it's good.
Recall. Yeah, exactly. If I had this, we know how to do this. I know I'm flipping around a little bit, but I want to really make this parallel clear. How would I write the two cases?
X minus 1.
I leave everything the same, like we already did.
And -2.
And the other case would be
X minus 1.
change the sign, right? Well, how do inequalities work when I change the sign? I flip the sign, right? So either this has got to be less than 2, that's my ceiling, and it's got to be greater than or equal to -2. So I don't want you, not only can you not go further than 2 away from me, like I'm thinking of ceiling, but further than 2 away, but you also can't get further than -2 down. I want you to be more than -2 and less than 2 away from me, right? I want you to be within 2 feet of me, right? All right. And that's really the same cases again. It's the same exact cases. The same thing, change the sign. It's just that with the inequality, I got to flip the inequality. With the equal sign, when I flip it, it's still a freaking equal sign, so it doesn't even show up. All right, like maybe. And then I just, let's see if we get what we're supposed to get. So x less than or equal to 3, and x greater than -1, that means it's got to be in here. It's got to be both. This number here, is it less than 3? Is -2 less than 3?
Yeah.
Yes, but is it also greater than -1? No, that's why that's not an answer. It's got to be both. So let me show you the better way to set this up. So this is the idea behind it. But here's a nice way to set this up. I call this a sandwich. A sandwich is a sandwich that tastes really good. It's a sandwich. Because it's got bread, it's got stuff in the middle. So here's the beautiful thing about how to write this. I can write this. This is all nice and good. You can do it this way if you want to. It's beautiful. I can't say anything bad about it because it's awesome. But the better way to write this is to say that this has got to be in between 2 and -2. Watch. You ready?
But that would be your answer, what you just
No.
wrote?
Now you got to solve it. And watch. Some of you guys don't like it because it's got 3 sides. Aw, I'll show you why you shouldn't be concerned about that at all. But doesn't it have this in it?
Yeah.
And if this is greater than this, then -2 is less than this, right? We'll try it again. If x minus 1 is bigger than -2, then -2 must be
Small.
less than that. It's got both of them in there at once, doesn't it?
Yeah.
And it looks algebraically like it looks visually. It's contained. This is between these two. So what's x between? Now watch. What do? Don't you add 1 to both sides?
Yeah.
Now I add 1 to all sides. I mean, that's the generalization. If you do something to one side, you must do it to all sides. We just normally only have 2 sides. So don't make a big deal out of that. You do what you would normally do, just do it to everybody.
So if you look at it as terms, could you look at it like that? You know, as terms, is like 3 terms in a sense that you're, on each side of that, whatever where you're doing.
Sure.
Does that make sense?
Sure. So like here, I add 1 to all sides. But if I would have said that before today, you would have been like, what do you mean all sides? 2 sides, dude. How could it be more than 2 sides? Well, there you go. Right? If I add 1 to the inside, I better add 1 to the left and right side also, to keep the balance.
And you have to start with the middle, whatever's in the middle, right?
You were trying to get x by itself. That's what's totally driving what you do.
Okay.
And what do you get?
You get
One.
-1.
-1.
It's less than or equal to
I love this. X is between what?
the 2 of them.
-1. And x is between -1 and 3. Isn't that exactly what it looks like? X is between -1 and 3. So again, like I said, you could do it this way, or you could do it that way, whichever way
And
makes
your
sense.
answer would be the last one you just did.
Yep, that's the answer. That's what it is. Interval notation, then it would be graphically, and then interval notation, graphically, and this is just algebraically with answers. You have to give it to me all ways.
Interval notation graphic.
Yeah, answer here algebraically, graphically, interval notationally. Yes, Jeff. All right, let's try another one. I'm going to try to go straight for this. Let me see if I can win some of you guys over a little bit. Let's just do less than.
So we don't put or in our answer, we put and, right?
Yeah, that's the thing I don't like about this method is you have to remember this is an and. If you want somebody to stay close to you, you would say don't get further away than this that way, and don't get further than that. You gotta do both. If you want somebody to stay the hell away from you, which is where the restraining order comes in, right? Stay the hell away from me, right? Be at least this far that way or this far that way. Or, oh shit. I mean, it just comes out. So if you do it this way, you got to remember it's an and.
But with that way, you could also set it up to the bottom.
Totally. And this is so much better.
No, I mean like you could like see how it's like x this way 3, x this way -1. So we'd obviously know -1 goes that way towards x, and then the x.
Well,
goes that
-1
way
is
towards
below x and x is below 3.
Yeah, so you could set it
x
up
is
like the
between
bottom of the
-1 and
answer.
3. Yeah, sure, of course.
Okay.
You can start this way and then set it up like that. All right. So let's see if we can do this. 3x minus 1. Oh, red's not good. Poor little red. 3x minus 1. I want it to be at most 8, right? And at least -8. So that captures that idea of the 2 cases all in one line. It's kind of nice. Or you could do it's that and 3x minus 1 greater than -8 to flip the sign, right? Either way you want to do it. You can do it this way or that way. I'm just trying to win you guys over to this way because it's just more direct. Yes?
You said you flipped the sign because you made it negative, but it's the same.
No.
say that, yeah.
The x is on the other side. How would I read this? If -8 is less than this, then this is how related to -8? It must be, if -8 is less than this is bigger than -8.
But technically, you really don't.
So did I switch the sign? Did I switch the sign?
You did.
Yes.
On the other end, no.
It's just that here I've written it the other way. I've just mirror imaged it, right? Is 7 bigger than 4?
Yes.
Yes. But 4 is
Less than.
less than 7. So if I just mirror image it, that's going to turn, of course, right? So that's got the mirror image of it in. So I can write this in the middle of those two, instead of this on the same side and those got to flip. I mean, to me, that makes less sense. This is that's between that and that.
It's still pointing at the 8, if I look at it that way. I'm trying to do it visually on my side.
It's pointing at the 8. What does it mean when it points at something? That is
The lowest end.
that's the smaller dude, right? Which is what would happen if that flipped. Then the 8 would be smaller instead of bigger. Yeah.
Okay.
That's my fourth puberty. So then, and now how do I solve this?
Get rid of the 1.
Yeah, you just say, what would you do if that wasn't there? You would add 1. Well, you do the same thing. You just make sure you do it everywhere. That's all. Don't let that be a big deal. It's got 3 sides. Who cares? Negative 7 less than 3x less than 9. Then I always get somebody that like adds 7. They're trying to kill a side or something. But if you add 7, this is a 0. It doesn't. The side doesn't just go away. I don't like the side being there. Let me kill it. No, you can't. Too bad. You can't kill it. You can make it 0 and it's still there.
Can I just do one big line, put a 3 under it, or do I have to?
I mean, technically, sure, I know what you mean, but I mean, that could lead to mistakes later, but yeah, okay. Yeah.
So if the 3x of the negative 3x, then would all the signs
Totally.
flip? Okay.
I would divide by negative 3, and then the signs would flip. And I showed you why you flip the signs, right? We talked about
Are
that.
you saying when you divide it by a negative?
If this was a negative 3, and I divide by negative 3, then the signs would have to flip. Yeah. Or multiply, exactly, because multiplication is division. You're at the stage where I can say that. We know that that's true, don't we? When I divide by something, I can just multiply by its. So division does not exist.
So we divide by
There is no spoon.
So we divide by negative.
Yes. Sorry. And again, just to remind you guys, which one's bigger?
Oh, 1.
If I divide or multiply by negative 1, don't these change sign? Which one's bigger now? What happened? Alright, so it's got to happen. That's all. Why does it happen? Because it's got to. I love that answer. I can finally say that.
Oh, sorry. Isn't the other way easier as far as like when we get into fractions in the middle and
Nope.
stuff?
Not really. To me, it's harder because then you're writing more shit out. How many times did I write 3x minus 1 here? Once. If I do the other way, I got to write twice. To me, that's more work. I am trying to push you guys in this direction, but you don't have to do it this way. You can do it the other way if you want to. All right.
No, I like that one better.
So less than means stay close to me because absolute value is distance, right? So if it's an absolute value less than, your answer's got to end up like this. Oh, before I get too far away, how do I graph this?
Between minus.
I don't care about, don't freaking try to find negative 7/3. That's math 88 shit. You're here now. I think you can find it. Just bam, negative 7/3. Just make sure they're on the right side. Okay. And now here's the important thing. What symbol do I put on those? Good, parentheses. I know it used to be open circle. Now just do half of an open circle. Right? That's why it's parentheses. Right? The bracket is when I want to include it. And doesn't it look like part of the letter I for include? Right? That's how you remember what to do when. So then parentheses. So how do I write that in interval notation?
Negative 7/3.
It's basically already written for me. From negative 7/3 using the symbol up to 3. So I'm going to ask you, just like on the practice test number 2, solve it, graph it, interval notation it. Did I restart the camera?
Yeah.
Actually,
Oh, thank God. Okay. So, obviously, what do we still have to do? One last thing before we take a break and then do review. We did less than, we got to do greater than. So if I want the distance to be more than something, that's why I said we can bring restraining orders into math, right? And there was one semester I had one student file a restraining order against another student that was in the same class. That was exciting. Yeah, I was excited. That's all I want to say about that. That semester was awesome. The school and I were like, what do we do with this shit? They sit really far apart from me. That was really neat. I could probably write a book about everything that's happened. Pregnant women standing outside my door yelling at people. That was awesome. I just came over and said, no, and closed the door. Go away. Go away. Or sorry.
Say it again what you said about the less than. The less than means it is,
Yeah, so this is distance, right? No, the distance being less than, so it makes sense my answer should come up like this. Stay close to me.
Okay.
Stay close. That's why the answer comes up like this.
got it.
If it's greater than, stay the hell. Now, do it. When you say stay away from me, like people coming over there, paparazzi, stay away from me. You would do like that. So the picture's going to look like that. Shade this way, shade that way. Stay away from me. Here I am. Stay the hell away from me. So then you know if your answer's looking right at the end.
Wait, I'm sorry. How do you know which way to go again?
It's less than. So if I want the distance to be less than something, I don't want you to get very far away from me.
Okay.
That's why this image makes sense.
Okay.
Here I am in the middle. I don't want you to get very far away from me, so stay close. Come here, stay close to me, right? Or, oh my God, you people get away from me. That would be this case. That would be, let's try a nice easy one. Let's try one we can do visually. So here's 4. I want all the numbers that are at least 6 away. So what is 6 away from 4 this direction? 10. And what's 6 away from 4 this direction?
-2.
Negative.
So can I be here? Is that at least 6 away from 4? No. -2 is the closest I can get, isn't it? On this side, so it's got to be, yeah, I got this. So it's got to be everything up here. All these are fine. That's at least 6 away. That's more than 6. That's good. That's what I want. It's more than 6 away. That's why I know the answer is going to look like that. And the same thing with 10. I want you to be more than 6 away. So there's 6 away and more. So like that. So this is the one. Do you notice why algebraically I can write it like this? Is because I know it's all going to end up connected. Are these connected? So I can't write that in one single statement. I've got to write the 2 separate ones. Right? So where can you be? If I'm here, where could you be? If I file this, you can be, I have to be more than 600 feet away from me, whatever. More than whatever, 6 feet. That's a really bad restraining order. Right? Yeah. Throw stuff at you. I'm sorry. But I had a really stupid judge. You know, more than 6. Where could you be? You could either be here. Or there. Not that it's fixed here. Or there, right? So or is the key word for this. You can be there or there and be fine. Right? So how do I write this then? The 2 cases the same as before. The first case is everything's the same. I mean, if this number is already bigger than 6, then won't the absolute value be bigger than 6? Of course. Think about it. Of course. Give me a number bigger than 6. 7. What's the absolute value of 7? 7 is already bigger than 6, so of course it's going to be true, right? Or, give me a negative number that would make this true. Would -5 make that true?
Yeah.
What's the absolute value of -5? Is that bigger than 6? Okay, give me a negative number that makes it true.
-9.
-9, -10, anything that's less than -6, right? So, and remember, we're going to do what to the 60? What we're going to do in the second case? Flip the sign, make it negative, right? So that makes sense though, because for the absolute value to end up bigger than 6, my negative numbers have to be smaller than -6. They have to be more negative, which means they're smaller, right? -10, -20. Maybe. Or if you don't like all that and solve concepts, this is process, the same, or change the sign, so flip the sign. Right? It's the same thing we did earlier. It's just that when I turn an equal sign around, it's still an equal sign, right? But it's the same thing I'm doing. And then I just solve both. So I get, what do I get here?
10.
X greater than equal to 10, that's this piece, right? X bigger than equal to 10, bam. Or, what's that 2 there? Look at me thinking ahead. Or less than or equal to -2, that's that piece down there. Now the exciting part of this is, how do you write this in interval notation?
It's the bracket now, right?
Yeah, the bracket's got to be here, but what's the lowest this could be?
It's infinity, negative
Infinity.
infinity.
Negative infinity.
Bracket.
Now here's the thing. Can you get to infinity?
Oh no, so it's a
It's always a parenthesis on infinity. If you put a bracket, that means you got to infinity. You can pick it up. Here's infinity. Where do you want it? You know, that would be when you transcend and you go to nirvana, right? Not the band, but the state, right? Or you're powdered and you become pure electricity. Have you ever seen powder? No. From negative infinity up to what? -2. Bam. I don't know if you guys have ever seen this next symbol.
Why is that negative infinity over -2 though? I'm like a little bit confused with the negative infinity.
Alright, real quick.
Oh, because it's less than or equal to, so it could be any
Yeah,
number.
where do I stop? Where do I stop shading? I never stop, which means I go down to negative infinity.
So then, oh, sorry.
What about 10?
Alright?
So that would apply to
Or,
any less than or equal to sign, right?
that's the math symbol for or.
What?
Yeah.
I call this skip. Watch how this makes sense. From negative infinity to -2, skip up to 10. So I call this skip. Right? Just give it a name. But, you know, skip, not skip like in hey skip. But you skip. Skip from -2 up to what? Start over again at 10. And then where do you stop?
Infinity.
You never. That's what you mean by this. You never stop. Ain't no part. Like
So
infinity.
it's bracket, okay, so the bracket is on the 10 and the 2.
Totally. I want to include the 10 and the -2, but you can't include infinity because that would mean you can get there. Infinity means you never stop. Yes.
So if it's not less than or equal to, it's
Yes. So if this would have been this,
yeah, parentheses.
the only difference would have been parentheses
Right.
on the -2 and the 10. Yeah. That would have been the only difference because then I could not include them. It's not allowed to equal them. This is allowed to equal these. So that's why I include them.
What is that
Wait,
called
why-
again? Down there?
Say again?
Sorry, what is that called?
Interval notation.
Okay.
And this is the or symbol, but I call it skip. Negative infinity, negative, skip up to 10 to infinity.
Why'd you put or? Don't you put and on those?
And is for the less thans, or is for the greater thans. Why?
Oh.
Because I can't say that you can be down here and up here. What number is down here and up here? Is there any number that does that?
No.
No. So I can't use and here. It's there or there.
But there's a less than and a greater than on these.
So, watch this. All right. I was trying, well, let's see.
Are you saying just the equal to
You
sign,
ready?
right?
You ready? Less than 3. Less than 3 would be forever that way, right?
Mm-hmm.
All right. Greater than -7/3 would be forever that way, right?
Mm-hmm.
But I want the answers that are
Not including that.
that way and that way. So that would end up in the middle. That's why I use and here. Not only do they have to be less than 3, what else do they have to do? They also, and they have to be greater than -7. That's why this is an and. If you do it this way, do you have to worry about that? No. Yes.
Can you rewrite that problem that you're working on now, the x minus 4? Can you rewrite it as the one you said, the preferred method? You know,
No, it's preferred for this, and I'll show you why. One thing is because you know what it's going to look like. I want it to be greater. But if you wrote it in one line, wouldn't it be this? It would be 6 less than x minus 4 less than or equal to -6. Now you guys might look at that and say, what's wrong with that? It's a bunch of letters and numbers like always. But that's just saying that 6 is less than -6. That's a neat thing to be able to say. Is 6 less than -6? No. No. So you can't write that. But here, is -7/3 less than 3? Or is -8 less than 8?
So only on the less thans you do that,
Yeah.
and on the other greater thans you do.
And why does it make sense though? Why does it make sense? Less than means stay close to me.
Right.
So I should be able to write it in a compact form. Greater than says stay the hell away. Either that way or that way. See how I'm trying to drag it out? Right? And that's why it's separate. Everything's separate. See, the answer's separate. The equations are separate because it's a separate idea. Right? Can't cross anything else. All right. Do you guys want to take a break? Yeah, so I want to take a break. All right. I'm going to run to my office, start the upload. I'll grab the other.